So the very first thing we learn about in calculus is limits. And limits are kind of an idea of what happens to the value of the function. In other words, what happens to the y value of the function as the x value approaches something. Okay? So it's not asking, like a lot of times in math or in the past, you learn like, if I had f of x was equal to x squared, if I say f of 1, I'm asking you, f of 2, for example, is 2 squared, and that's equal to 4. That's telling you when x equals 2, y is equal to 4. With limits, we care more about is, as x approaches 2, what does y approach? Now, it's a subtle difference, and I think we start off by explaining graphically why it may be different between the value of the function and what's getting closer to it, right? Now, when we say getting closer, there's kind of two ways we can get closer to something. We can either come from the left direction or the right direction. So let's look at some example problems so you can kind of like understand how this works. So I have a graph here, and I want to figure out what the limit is. This notation here, this limit as x approaches 1 with a minus sign, this is saying what does the y value of the function approach as x approaches 1 from the left. So here is x equals 1, and I'm approaching it from the left. And graphically, the way you look at it is you say, like, well, if I'm approaching 1 from the left, what is the y value doing? The y value is approaching positive 2 in this case. Okay? How about this? So this is 2. How about when it approaches 1 with a plus sign? The plus sign denotes what is the value of the limit. What does the y value do as x approaches 1, but from the right? So in this case, you would follow the curve, and you're approaching 1 here, right? Here's x equal to 1, and you're approaching it, but now you're coming from the right direction, from values greater than 1. That's why it's a plus sign, because it means values greater than 1. And what is the y value doing? It's getting closer and closer to this y value here, which is also 2. Okay? Now, if the left and the right approach the same value, the same limit, then we say that the limit as x approaches 1 is equal to 2. So if the left and the right approach the same value, then we say the limit exists, and so as x approaches 1, the value of the function also approaches 2. Okay? Now, this is actually, in this example, this is different than what is the value at x equals 1. The value of x equals 1 is this dot right here. At 1, you see they put a little hole here. A hole indicates that the function's not there. It's actually right there, so this is equal to 1. Okay, because the y value at x equals 1 is this dot, which is 1. How about the limit as x approaches 0 from the left? Well, here is 0 over here. And the left, we can't see anything to the left. So from the left, we say it does not exist because there's no part of the graph that's to the left of 0. How about approaching 0 with the plus sign? From the right means we follow 0 and we approach it from the right, and we're going to approach positive 1 there. Okay, so that's kind of how that works. Let's look at another example here, like number 2 down here. Okay. So what is the limit as x approaches 1 from the left? Well, here's 1, and we're now approaching it from the left. We're going up like this. Okay? So what is the y value approaching? Notice I'm not caring what happens at 1. I'm just saying, what does the y value approach as I go to 1 from the left? And I would get positive 2 here. The y value is approaching positive 2. How about coming from the right? Approaching 1 from the right would be following this curve here. Because here's 1, and we're following the graph, and then you can see the y value is going to approach 0 there. And because the left and the right approach 2 different values, then we say the limit as x approaches 1 does not exist. Okay? And then f of 1 is differently. F of 1 is the value of the function at 1, which in this case is 1. Okay? Let's look at number 3 here. Okay, the limit as x approaches 1, the minus sign is from the left, so I'm going to follow the curve from the left. And it just goes up and up and up, so we actually call that infinity, positive infinity. How about from the right? As you approach 1 from the right, we just go up and up and up. Again, that is positive infinity. And so we say because the left and the right are both positive infinity, we say as x approaches 1, this also approaches positive infinity. Now, what is the value at 1? This is an asymptote, so it actually never crosses there. So this does not exist. So note that we can talk about the limit as it going up to infinity, but the value at 1 does not exist. How about the limit as x approaches 2 from the left? So we're approaching 2. Here's x equals 2. And we're coming from the left. What is the y value going to approach? 0. How about 0 from the right? Here's x equals 0. And what's the y value going to approach as we approach 0 from the right? Also going to be 0. Okay? Let's look at number 4 here. What's the limit as x approaches 1 from the left? That's 2. How about 1 from the right? Right, here's 1. 1 from the right, the y value also approaches 2. So because the left and the right is the same, the value of the limit itself is also 2. And the value of the function is right up here, which is also 2. So all of these are 2 in this instance. Okay? Let's look at this one. The limit as x approaches negative 2 from the left. So here's negative 2, and I'm approaching from the left. The y value approaches 2. How about 2 from the right? Or negative 2 from the right, also approaching 2. So because the left and the right, negative 2, it approaches the same, that's also equal to 2. How about the value of the function at 2? There's a hole here. The value of the function is right down here, which is 0. Okay. Do the same thing. What is the value of 2 from the left? That goes to 2. 2 from the right, also the y value approaches 2. So because the left and the right are the same, they approach 2. What is the value of the function f of 2? F of 2 just has a hole here. There's no dot anywhere else. So this is undefined. Okay. All right. Limit as x approaches 0 from the left. I'm following the curve. I'm approaching 0 here from the left. The graph, the curve approaches positive 4. How about approaching 0 from the right? The y value would approach negative 4. Because these don't match, from the left and the right they are different, the limit itself does not exist. And what is the value of the function at 0? Well, there's a dot here right at 0, so when x is 0, the y value is 0 itself. Okay, so that's graphically how you interpret limits, okay, looking at it from a graph and from a picture. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.